Hi, and welcome to the 9th episode of Advanced Python. In today's episode, we will be covering decorators. Decorators are a tool in Python which allow us to modify the behavior of a function without changing said function. It is also possible to create a decorator which works with multiple functions, so that instead of having to modify each of your functions separately, you can simply create a single decorator which will work for all of your functions. And if there's a change which you would like to make for each of your functions, you can use a decorator for that as well. Everything in Python revolves around objects, and pretty much everything you can see in Python are objects. Functions are no exception to that, and they are objects themselves as well, which means that they can be passed on as parameters to other functions. And that's exactly what decorators take the advantage of. In short, decorators are functions which take a function as a parameter and then return another function. To showcase how functions are objects, we can create a single line function which will simply display hello. Define func, and the only thing it does is print hello. Now that we have a function, we could call it by using its name with brackets next to it. However, because functions are objects, what we can also do is actually assign our function to a variable. It is important to note that when you're assigning a function to a variable, you shouldn't include brackets after the name of the function, because then you wouldn't be assigning the function to a variable, you would be assigning what that function returns. Now that our x variable stores our func function, we can actually see that if we try to print our x. As you can see, the results we're getting in the console is the object function func. Now, because of that, we can actually call that function from our x variable by simply including brackets next to our x. Doing so will execute the function which is stored in our variable. As you can see, it prints hello. Now we can use that knowledge to make a function which takes in another function and then returns it with additional or changed functionality. I will start by defining a function which I will call printer that will be taking in a single parameter called func, which will be our function. Now, inside of our function, I will create a second nested function, which I will call paper. Our paper function will not be taking any parameters at the moment. However, inside of that function, we will do three things. The first one will be simply printing a message, started printing. Then we will call our function which was passed in, so our func, after which we will print another message saying finished printing. Now that we have our nested function, we will pass it through a return statement in our printer function, so that when our printer function is called, it returns the paper function object. Basically, what we have done now is created a function which takes in a function as a parameter, gives it additional functionality, and then returns it as a function object. To call our function, first we need functions which can be actually passed on to it, so I will create two functions now. The first one called news1 and the second one called news2. The first function simply prints an athlete broke a leg, and the second one prints the president is a human. All of our functions are ready now, so we can finally use our printer function. We can create a variable called printNews1 and assign it to the return of our printer function, which was passed on a parameter of our news1 function object, and do the same for news2. And now, just like in our first example, we have new variables which actually store functions in them, and we can call those functions using brackets next to the name of the variable. If we try it on our print news1, you can see that our console says started printing, an athlete broke a leg, and then finished printing. So now we've actually modified the functionality of our news1 function and our news2 function without changing those functions directly. We can also call our print news2, and this time our result will be started printing, the president is a human, finished printing. The functionality which we added to those functions in this simple example is just printing started printing before the function and then finished printing after the function. As you probably noticed, there is quite a lot of writing, and you actually have to come up with new names for variables, and then you have to memorize additional variables to call your previous functions from, and it's not really ideal. Luckily, there is a way to deal with that. Instead of using different names, we can actually use the original name of the function as the name of the variable. So our print news1, we can change to simply news1 and print news2 to news2. If we do it this way, we don't have any additional names to remember, and we can simply call the functions just like we did previously, but now they have additional functionality. So if we call news1 and news2, even though it should only print an athlete broke a leg and then the president is a human, it's going to print our additional messages everywhere in between, just like previously. Still, doing it this way is a bit tricky, and it might not always be obvious where you should put that line of code at. But fortunately for us again, Python has a built-in method for dealing with this situation. Instead of using those two lines, we can do the exact same thing, however slightly differently. Our first line, news1 equals printer news1, can be completely replaced by going above our news1 function and typing the @ symbol followed by the name of our decorator. So in our case, it's called printer. Therefore, above our news1 function, we're going to write @printer. This line of code always goes straight above our function and does the exact same thing as this line does, but it's slightly easier to use. We can replace our news2 as well by simply adding @printer above our second function, and this is the main way you should be assigning decorators to your function. Next thing to cover would be how to actually make a decorator which can work with functions that take in any amount of parameters, because our current decorator only works with functions which don't take in any parameters. We can test it by passing a single parameter to our news1 function and then adding, let's say, 3 parameters to our news2 function. Our functions now take in parameters, so while calling them, we actually have to pass on those parameters. But as you can see, if I try to actually give our function a parameter, it's not going to work, because where we are actually passing those parameters is not to your news function, but instead you're passing them to your paper function. So if we want our decorated functions to be able to take in parameters, we have to make sure our paper function takes in the same amount of parameters as the function does. And then when paper function does take that amount of parameters, we can pass them on to our func, which only then is actually our news1 and news2 function, because this is exactly where it's being called. There is a way to fix that and make our decorator work with any function despite any amount of parameters without having to create multiple decorators. We can do that by modifying our paper function to take in 2 things. The first thing will be caret args, which will be all of our positional arguments, and the second will be double caret quarks, which are the keyword arguments. Now we simply go to our func line, which calls our functions, and we pass on the same parameters. So our caret args and our double caret quarks. This way our decorator now works with functions despite any amount of parameters they might take. So if I run it, you can see everything works fine and our parameters reach their desired destination. We still have one more issue to take care of, however, and that is when our functions return a value, because we have no actual way of getting that returned value at the moment. So I will modify our news1 function to return a simple string saying I'm sold. So if we actually go here and try to print our news1, you will be able to notice that even though it's supposed to print our return, it prints out none because it doesn't actually get returned. Just like I mentioned a second ago, where we actually call our function is in this line with the name of func. So our returned value of I'm sold is actually being returned over here. So what we have to do now is assign our func return to a variable. I will call it val, and then after we finished printing, we will return our val. And if we run the program again, you can see that it now prints out I'm sold because we successfully returned the value from our function. And our decorator at this point is finished. We have created a simple decorator which works with functions with any amount of arguments, which can also return a value. And what it does is simply add a print statement of started printing before the function happens and finished printing after our function happens. So now that you know how decorators work, I will give you a useful example. Our example decorator will be checking if all of the parameters passed into a function are actually integers, and if they are not, it will give us specific information on which function got passed on a parameter which is not an integer. We will start by defining our decorator, which might seem slightly complex. We can call our decorator checkInt and give it a parameter called func. Inside of our checkInt function, we will create a nested function called isInt, which will take any amount of arguments signified by *args. Now I will define an array called arguments and then use a for loop to append every value from our args to our arguments. After that, we create an if statement to check if our arguments array actually contains any values, because we don't want to be checking if arguments passed in are integers if there is no arguments actually that has been passed in. If our if statement is true, we will create a for loop which goes through every argument in our arguments list and then one by one first turns the value into a string so that our try and except method can actually check if it is an integer, because if you would not turn your value into a string and your value would be a float number, it would not detect an error and allow a float value even though we're looking for integers. So first off, for arg in arguments, arg equals string arg. After that, we will put our try and except method to check if our arg is actually an integer. So try int arg except value error, and when the value error happens, we will do two things. The first one being sending a message telling us exactly which function has failed, and then we will be simply returning 0 so that our function returns something if it's expected to. We can actually get the name of the func that was passed in by typing in func._name_, and it will give us the name of the function. After our print statement, we return 0. After that, we still want our functions to be able to return their results, so we have to return our function at the end of our isInt function. Return func with all of the arguments. And then at the end of our checkInt function, we will simply return isInt without calling it. And that would be our entire decorator. It can be now used to check if all of the arguments passed into a function are actually integers, and if they are not, it will tell you what's wrong with them. We can test it by creating 3 different functions, all of which will use our newly created decorator. The first function, called addition, will take in any number of arguments and return their sum. Don't forget that we have to apply our decorator to our addition function by typing above it @checkInt, because that is the name of our decorator. The next function, called give5, will take in no arguments and simply return 5. And then our third and final function will be called +-, and it will take in 2 arguments and then return the value of 0 plus the first argument minus the second one. We can now check if everything works by calling our functions, and we can use print statements to see what they return. We will call the addition function by passing it on 1, 2, 3, 4, and 5. The give5 function, passing it nothing, and our +- function by giving it, let's say, 10 and 5. If we run it now, you can see that we get returned 15, 5, and 5, just like we would expect, so that means our decorator is fully functional. But we have one more thing to check, and it's that what happens in case we actually pass in non-integer values, and if our value error actually catches it and gives us our statement. We can do that by calling our addition function again, and this time passing it non-integer values. I will pass it on 1.5, 2.78, and 9.1. What should happen now is we should get our print statement saying which function failed, and also we should get a print of 0 because we're printing the return of this function, and in case of non-integer values, it's supposed to return 0. We can run it to test it, and as you can see, we get printed function addition was passed a non-integer value, and then it prints out 0. I hope you learned something useful about decorators today, and that would be it. See ya!